So, hello, good morning, everyone. I would like to welcome you to my talk, which is a bit about supercomputing and a bit about trading, actually both. But first of all, I would like to thank the organizers for having me. It's here the third time actually here in Belgrade, and I really still enjoy the community here, the spirit which is here, which connects people, which inspires people to talk about data, to make most of the data. And I really immediately connected from the first time on with this kind of spirit, which I also have when I created Quantargo to enable people to use data, to inspire people to do great things with data, and last but not least, to do good things with data, not to exploit other people or use their information for bad things. And also, I'm very glad that I can co-organize now I'm also co-organizer now of the event in Austria. We're planning the DSC Austria in end of May, June, something next year. For the sake of COVID. I'm not sure about the COVID terms, but it will be virtual for sure, and I hope you can join. And as I know how much effort it takes to organize a conference like this, again, big thank you to the organizers. I know how crazy it is to organize something like this, and for all the people who are here, really grateful, first of all, Alex Linz, who put so much effort in it, and without him and all the others, it wouldn't happen and it wouldn't inspire people. So again, big thank you to the organizers. First of all, the ones who might have seen some talks before, it's again a serverless talk. It's a technology we use at Quantargo quite heavily. So we have a course platform where you have interactive code exercises, and those exercises are powered by serverless computing. For all of you who don't know what it is, you can imagine a tiny piece of a virtual machine, which is each time you start it, so each time you invoke it, some virtual machine gets started up, executes the code, and then returns the result. And so there's no permanent server running. So serverless is actually still servers involved, but those servers manage those tiny pieces of computations, which then power up some virtual instance, do some computations, and then turn down. And I think this technology is a bit unappreciated, especially in the data science community, because it's very cheap. It can be run highly in parallel, so you can do lots of parallel computations. And last but not least, you don't have to manage a lot of things. So if you compare it to some Kubernetes clusters where you need a team of people who manage it, in the end, serverless, for example, by big cloud providers, enable you to just focus on the application, but not on the computation behind. And since we don't have such a big DevOps team, it also helps us so much. And we're still on this serverless journey and still like to show off what you can do actually with the technology combined with data science. And in the talk today, I would like to talk about also combining it with trading. So I have some background in trading. So big disclaimer here, it won't make you rich. But I hope I can give you the idea how you could implement some strategies on your own and how you can use the technology for also not only trading, but optimizing other models in very short time. So this is a screenshot of Quantico Workspace. We've released it as a product in September, and it basically looks like a normal editor. So you have some editor screen, you have also some viewer window where you can show off the plots. This is an example where we built a model to predict Airbnb prices, so Airbnb prices in Vienna. Based on that kind of prediction, we calculated some discount and to find cheap apartments. But this is actually not the topic of this talk. But the workspace is very different from some typical editors. So you have to imagine there's no permanent machine running behind. There's no computer running the whole time, which you need to start up. But actually each invocation even if you just put in 1+1 in the editor, starts up a virtual machine which executes the code and returns the results. And you can use the Quantargo workspace also just as a normal data science workspace, as I've said, but this kind of scheme or this kind of serverless backend enables the workspace to, in the end, also execute a lot of parallel computations based on the same data, maybe with a different parameterization. So we have lots of community workspaces. You can also check them online. We also have some trading strategies, some model which, based on the Dodge mentions of Elon Musk, tries to determine if if the Dodge coin somehow, went up or down. So lots of workspaces created by our own or by the community. And the very special thing about the Quantargo workspace is everything you have there can also be accessed via an API. So you can either work basically everything you can do within the editor, like everything like executing code, entering code, uploading files, installing packages, everything you can do also via an API. So you can automate everything you have there. You don't have to care about running a server or anything. Just upload some R or Python code and access it, basically. So, as I've mentioned, everything you can do via the web frontend, you can also do via the REST API. And the workspace basically combines all the code, all the objects, all the packages, the runtime R or Python. Everything is there bundled together and just works. Okay, so now I've just introduced the workspace. So the workspace is great to just take your models, upload them, access your models via an API. Behind the scenes, you have serverless technologies. So even if you have a big spike in demand, it automatically scales up by default. For example, we're using AWS Lambda. It scales up to even 1,000 Lambdas in parallel. So even if you have huge spikes, typically if you run a model and, I don't know, for anybody who has watched web traffic is never constant, it is very spiky actually, then this infrastructure very quickly scales up or down. And for trading, this is very interesting actually, or for optimization, because you can exactly run the same thing just in an optimization use case and have a supercomputer with 1,000 cores at your fingertips, which dramatically changes the way you, in the end, can model or develop models. And for trading, this kind of workspace is interesting because you also just upload your trading model. You can also include credentials and access some data provider, and then you can schedule it based on some specific time intervals. So we also did some collaboration with, it's a German startup, Lemon Markets. You might not have heard of them, they're quite new. But what they provide is some kind of brokerage service which offers some API to trade, I think, mostly German stocks, but also international stocks. And we are accessing their API through the Quantargo workspace and have implemented some very basic portfolio model there. So this just works. Of course, crypto exchanges are great because all the APIs you can, crypto exchanges typically have very nice REST APIs. So everything you can do with REST is a perfect fit for this kind of workspace. Because we've also included secrets, which are encrypted and used by the workspace. You can schedule it, and of course, you can also access it via an API. So let's talk about trading optimization. So this part was now just a small recap. What serverless is, it's small instances which just spin up very quickly, which can spin up in, you can spin up hundreds or even thousands of them in just a few seconds, and to run actually huge computations on them without any more effort. Now I come to trading strategies. So for anybody of you, does anybody of you have experience in trading or has developed something? Okay, cool. So coming from, I've seen both worlds. Actually, originally I'm a quant and then moved into the data science world, as most of them did. So trading is, in a sense, a bit different because the data is very noisy. So typical data science models deal with data which is based on maybe customers or transactions, or actually things which have some kind of stable behavior, more stable behavior. In terms of trading, since there's so many parties which act against each other, and so many huge computers which are optimizing each and every bits out of the data, in the end, you have a very noisy data set, and doing very basic stuff, as we will see, won't bring you so much improvement. So overfitting is a huge issue, and you always need to deal with this, especially if you're using more complex models like, I don't know, boosting trees, or if you're using deep learning even. And most typically, trading models try to optimize some kind of risk-adjusted return. So you want to improve the return based on some kind of volatility which is involved with the returns. Maybe you also want to control for drawdowns or something like that. What I would like to present you is something now since it's a data science conference, I thought, okay, let's do something bit more involved. So what I would like to show here is so it's actually an XGBoost model. I've taken a bunch of technical indicators, maybe you know a bunch of them, like some basic momentum, moving average differences, RSI, and so on. So just a bunch of technical indicators, nothing special. Downloaded some data from, I think it was Coinbase, so hourly Bitcoin, US dollar data from Coinbase. And the basic rule, which is, of course, nothing is perfect, but the basic rule was here to predict next days, not days return, sorry, that's wrong on the slides, but next hour's return. And if the prediction is higher than 1%, then just buy. If it's lower than 1%, then sell. Again, no perfect strategy, but just to see how the model works. And since I've mentioned also overfitting, which is a huge issue, especially in trading, because the data is noisy, and of course we are using here an XGBoost model which is a highly optimized model and which you can easily overfit. You need to control somehow for this overfitting. And there are some strategies you can use. So most basically in machine learning, and also in trading, you should always have some kind of out-of-sample data set available, which you use to evaluate the model. And what I'm using here is some kind of, it's called work-forward optimization. So this kind of out-of-sample data set is always exactly behind the training data set. And so we're estimating the model only on unseen data. And also the performance results I show are only based on data which has not been used on the training data set, which is very important. Because otherwise you get the impression that your model is incredibly good, that you are already rich. But unfortunately, those models tend to overfit a lot. And you really need to take care of this. So in general, if you're doing some kind of time series optimization or a modeling on time series, this kind of walk-forward optimization gives you a better sense of overfitting and should reduce the risk, at least, of overfitting. So this is what we're using here. And of course, to put something else on top, I hope I didn't confuse it too much, we're now using serverless here. Again, serverless, those little instances which spin up and do something. And what we're doing is some grid search. So as I've mentioned, I'm using an XGBoost model. There are some hyperparameters which can be tuned, like number of trees, tree depth, number of data points in each leaf, and so on. So some hyperparameters. And we're doing some grid search on this. So based on this parameter set, we're estimating all of the parameter combinations. And since this kind of computation is very independent, so each computation is independent from each other, it can be perfectly parallelized. So if you want, each serverless computation then in the end does one computation of exactly one parameter set. And based on the combination of all of them, we then estimate which parameter is the best. And the whole idea now of this serverless, and I hope you can take this away from the talk, is now actually it doesn't really matter if we run it on 5 cores, on 10 cores, on 100 cores, on 1,000 cores. It really doesn't matter cost-wise. It's actually, so it costs exactly the same with the cloud provider. And actually the costs are also not so high. So what you can do instead is, instead of running, for example, one core, one day, computation 1 day long, you can do it in 500 cores in 3 minutes, for example. Or you can do it in 1,000 cores in even less time. There's, of course, also some overhead involved. But what it brings for you as a data scientist or trader or whoever is that in the end, you have much higher iteration times. So the idea is that you don't have to wait longer time for each model to finish, but you can interactively optimize models, reiterate them, play around with them, spin up another 1,000 cores, have the results in 2 minutes back. And that's the whole idea, actually, where the whole time of developing such kind of models can be dramatically reduced. And the costs still stay the same. So for the cloud provider, it doesn't matter if you do it on 1 core or on 1,000 cores. So again, that's the trading strategy. The link is online, so you can also look up the code. So it's basically, again, hourly data on Bitcoin. I think the data ranges from 2016 till 2021. A bunch of technical indicators is involved, an XGBoost model, a bunch of hyperparameters like tree depth, trees, learning rate, and so on. So this is the strategy we want to optimize. Again, the data from 2016 to 2021. It's 12 time windows through the walk-forward optimization. The parameter set size, we've tried 100 and 1,000. So what we then ended up with is with 1,000 parameters. We set the lambda memory size to 2 gigabytes. You can even improve this. So what we've seen is the more you increase the memory size, the faster the lambdas also run. So you can also play around with this. And just to give you an idea how much it costs. So for us, it was 1,000 parameters took about 21 hours on 1 core. So the computation cost was for 1,000 parameters about €3. So in the end, what you end up with is you just put a bit money on it and you can run it in very short time. And again, Lambda is very comparable to Fargate, to another service, for example, from Amazon. So cost-wise, it's really still cheap. And you even have a free tier, which is huge. That's a very bad graph, actually. But this is the results from the optimization. So what you see here is we ran it on, so we increased the parallel lambda size, so from 1 to 1,000. And it was a parameter set of 1,000. And what you see is, especially at the beginning, it dramatically decreases because what we try to do is since we use, for example, 5 or 10 lambdas, then the parameterization, so the training, which takes longest, still stays in the queue, of course, and the quicker ones can quickly fill up with new computations. So what we've seen here is you can reduce the optimization time, in this case from about 21, 22 hours to, in this case, 12 minutes. So this is the gain, what you get here. Of course, the gains are getting less and less because there's, in our in our infrastructure, still a few overheads involved, but I just want to give you the idea how much it can increase the time, decrease the time, the computation time. And in the end, if you can reduce it so much, you can't even go for a coffee during optimization. So you get the results quite quickly. And in the end, for data scientists or for quants, it means you can come up with a model quite quickly. If you have a model in production, it also means you can do refitting quite quickly. You can do all those kinds of workflows in very short time without any interruptions in the end. And this is very powerful, the whole idea of having this kind of interactive feeling even during model optimization, tasks which take maybe days, just in a few minutes. So this is the resulting trading strategy. I don't know if you're into trading. I'm not sure. It's a Sharpe ratio of 0.01 based on this kind of walk-forward optimization, which typically in that industry you wouldn't like to trade. But I want to emphasize here it's the real results. So this is something which is not overfit, which is just based on out-of-sample data. And of course, the code is online, so feel free to improve. And if you're using serverless, the iteration times are very quick, so you can quickly iterate on this. So as a trading strategy, I'm not sure if I could recommend this, but I just want to give you an idea what came out. So the results, just as a recap here, we reduced the time, the computation time here from 21 hours to less than 12 minutes. Using 1,000 lambdas. In the serverless world, if you put now this into perspective, in my case, so I would even go so far that I would put as many parallel lambdas into work as you have parameter set. So if your parameter set is 1,000, I would go with 1,000 lambdas. If it's 10,000, you can go with 10,000, because cost-wise, it doesn't make any difference. So your execution time in the end, of course added with some overhead, actually then only depends on the longest computation, on the longest training run, so to say, on one parameter set. So the longest parameter set in the end determines your entire execution time. And this can be in a matter of minutes, not hours or days even. So this is something which I still need to wrap my head around, because normally I'm used to these kinds of, you have 8 cores, 10 cores, this runs for I don't know how many hours, to you have infinite number of cores. It just doesn't matter. And for this kind of trading problem, trading strategy optimization, it's a very good fit for these kinds of optimizations. So it's a very stable set of data, and you can easily iterate on this, easily optimize on this. So again, I hope this was interesting to you, and I hope that maybe in the shorter future also the data science community picks serverless up a bit more, because I think that it can dramatically increase the interactivity of your modeling and also the speed of development in the end. Again, costs are not, the only thing is cost, of course. You put in some euros and you get it even quicker. So it's very, in my opinion, it dramatically reduces optimization time. It's easier to understand and implement. You don't have to run a Kubernetes cluster. You just need to make sure that it runs on Lambda. If you're using Quantargo Workspace, of course, you can directly use that. Please talk to us. If not, we're also starting to open source some components which you can then use to implement the same thing in your own infrastructure. So what we've still seen here in our case, we reduced the time to 12 minutes. The longest time, or the longest calculation time of one parameter set was 2 minutes. So we still have an overhead in our infrastructure or and the parallel execution of 10 minutes. So we think that this still can be decreased further and optimized to make the optimization run even quicker. So maybe we can go to 3 minutes or so. But again, 3 minutes compared to 21 hours or maybe a few days, it's just a dramatic difference. It's not even a coffee break anymore. And I'm measuring lots of things in coffee breaks. So this is actually a cool thing. The only caveat I have to say here, at least for AWS, if you're using it as a cloud provider, you have a memory limit of 10 gigabytes. So if your data is bigger, you might run into a problem, or you might need to optimize that, or need to use Spark in the end. And of course, the setup might be more involving. So it makes sense if you have a very fixed or a specific type of optimization problem, then it makes sense to maybe consider the serverless route, because in the case of trading, it makes sense because it's very similar in the end. So that was the conclusion. I hope I could convince you that serverless is actually a cool technology which you can use even for data science, for optimization, and which can make your model development workflow way better. What I didn't achieve here is creating a trading strategy which performs extremely well. I also didn't put any effort in it, I have to admit. Otherwise, I couldn't present it for other reasons. But maybe it's a nice blueprint which gives you an inspiration how to use this and how you could implement machine learning models into trading. A few more words from my side. We are also offering a course platform, an online course platform with interactive courses. I mentioned it in the beginning. We have a new course available for Excel users. Please write us an email if you want access to that until the year end. We're searching for academic institutions and meetups, so partners who want to use the course offerings, who want to use some parts of our platform. We can offer them for free for academic institutions and meetups, so please contact us. And of course, what we're also now doing is creating the infrastructure to create your own courses. So if this is something interesting to you, for your communities maybe, or universities, please also contact us. We are searching for collaborators and want to make the course platform bigger. So that was it from my side. Thank you.
Questions?
Questions, yes.
Yeah.
Are there any questions in the audience? Yes.
Yeah, thank you for the nice presentation, really interesting. My question is about the data security. When I give my keys and stuff for the trading stuff, how it's encrypted in the background or how it works there?
It's encrypted using an AWS, so actually an AWS service from the cloud provider. So the encryption, so we don't see them actually in the database. So that's the idea.
Okay, thank you.
It's a very good question because trading is very sensitive, of course, security-wise. Yeah.
Is your model based on technical analysis, or you use some stochastic calculus, for example, because more of this model parameters not supported by any scientific method?
To be honest, I didn't put too much effort into the feature construction or something. So what I've just used is technical indicators, so a quite popular library from R to calculate all those RSIs and momentums and so on. And those indicators were just then put into the model, into an XGBoost model. So it's just technical indicators, typical technical indicators with an XGBoost model. No stochastic model or other more sophisticated stuff, to be honest. But again, you can improve that.
Okay, thank you.
Any other? Okay.
All right, Mario, thanks a lot. It was a really insightful presentation, especially with a very hot topic, and thank you. I just want to give you a little certificate of appreciation, and thank you once again for being the speaker on the Data Science Conference. Thanks.
Thank you.